welcome to today's webinar, Biosafety Cabinet Selection, the ABCs of BSCs. I am Cassie Saltman of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by LabConco. I'd like to now welcome our speaker for today's webinar, Elizabeth Dilley, Project Manager of Biosafety at LabConco. Elizabeth, you may now begin your presentation.
Thank you, Cassie, and thank you for the opportunity to present today. I'd like to welcome everyone and thank you for taking some time out of your day to learn about biosafety cabinets with us. On the agenda for today's talk, we're going to talk a little bit first about what are biosafety requirements, what is a biohazard, what are some basic kind of things to consider, what agencies are responsible for biosafety regulations. And this is going to focus mostly on US and Canadian standards, but there are standards elsewhere we'll discuss. And then we're going to talk a little bit about Class I versus Class II biosafety cabinets. What's the difference and when you would select each? And from there, we're going to dive into the specific Class II biosafety cabinets, the A, the B, and the C of Class II biosafety cabinets. And after that, we're going to have a brief question and answer session. I always like to start by just kind of defining what is a biohazard and why you would need biosafety cabinets in the first place. We get a lot of questions at LabConco regarding biosafety cabinets and their use. And so I like to kind of just outline and kind of lay out where we're talking about and what kind of hazards we're talking about when we talk about biohazards. In a very general sense, a biohazard is any kind of virus, bacteria, particulate that can affect plant, animal, or human life in any way. So these, again, could be viruses such as the flu viruses, which can affect several animals and humans as well, versus plant viruses that could be detrimental to various plant life. Any of these types of hazards, we need to be very careful with when we're handling them because exposure to them or release of them into the environment can be detrimental. So one of the first questions we often get is, can I use a fume hood or can I use a biosafety cabinet or which one do I need? So before we even get started too far into the talk, I want to outline a little bit about the differences between a traditional laboratory fume hood and then the biosafety cabinets that we're going to be talking about today. When somebody asks me if they can use a fume hood for their work, I always like to break it down to a very simple question. And that is, are they trying to trap chemical fumes or vapors, or are they trying to trap some type of aerosol? For biohazards, that could be a virus, that could be a mold, it could be a bacteria, it could be a fungus, anything like that, any kind of particulate-based hazard is what we would be talking about there. And the reason that we have these two very different types of hoods is that you never would want to handle a virus or a particulate or something like that in a fume hood because fume hoods don't have any type of filtration built into them. They typically carry all the fumes and vapors right out an exhaust stack out into the environment. We do not want to do this with biohazards. Okay, you always want to make sure biohazards are trapped in some kind of HEPA filtered enclosure. And that's the kind of thing we can get from a biosafety cabinet. So we'll talk more about biosafety cabinets later in the presentation. When it comes to classifying biohazards, every country has its different regulatory agencies. Within the United States, we primarily work with the CDC, and the CDC publishes a guide that's called the Biosafety and Biomedical Laboratories. Canada has their own kind of version of this guide, as well as the World Health Organization has a more global standard. Now, oftentimes we get calls people calling in saying, I have a specific hazard, what do I need to do? And the first place I like to send people when they're asking about how to work with biohazards is to check with their institutional guidance. So odds are your university or your organization has either an environmental health and safety office, or you might have a biosafety officer, or if you're in a small organization, you might contract out with an industrial hygienist, and they might have a background in biosafety. But always, first place you should go to is to check to see if you have anything like that within your organization, because that's really your best resource in-house for how to handle and how to work with various biohazards or samples that you may want to bring into your university. Next, you can look to the global standards. So this is kind of the book I mentioned to the right. The Biosafety in Microbiological and Biomedical Laboratories book is a free guide put out by the CDC. It's now currently on its 6th edition, and you can download this online. And this is really a complete guide to not only how you need to classify your biohazards, but what kind of steps and what kind of things you have to have in place in your laboratory to work with various hazards. This book will also outline what BSL level is required for your specific risk group of biohazard. Canada has a very similar standard, and the WHO has a general biosafety manual as well. Okay. Now, each of these books or each of these organizations tend to list biohazards by their risk group. So when I'm asking or when I'm looking at a specific biohazard, basically what I want to know is whatever I'm handling, I need to assign that to a certain group, risk group. Depending on how this biohazard, should I be exposed, is treated, that kind of defines what risk group it belongs in. So those that cause little or no pathology in humans, animals, or plants are typically kind of related as a risk group 1, which would correspond to a BSL 1 level of protection. Higher things, like if you're looking at tuberculosis, those do cause a pathology in people. However, there are also vaccines and medicines out for it. So those might be listed as a risk group 2 or 3, depending on the amount that you're working with. Risk group 4 would be those things like Ebola and some other ones, and those would be required to have BSL 4 level protections. So one of the questions we frequently get asked is what kind of cabinet or what kind of enclosures do I need for a BSL2 lab or for a BSL4 lab? This is really something, again, you have to work with your biosafety officer on and then go back to those resource guides to look at what they recommend. In general, the difference between the BSL 1, 2, 3, and 4 labs is not only that a biosafety cabinet may or may not be required, but it's also, do you need to have signage on your doors? Do you have to have a locking door? What kind of PPE you need to wear? For instance, a BSL 2 lab, you might be required to wear safety glasses, lab coat, and gloves, whereas a BSL 3, you might get into a mask, full face protection, and so on and so forth. BSL 4 labs often require a full positive pressure suit to protect you from the agent, as well as the biosafety cabinet and the other standards. Okay. Now, when it comes to our manufacturing design standards, so LabConco manufactures various types of Class 1 and Class 2 biosafety cabinets, as well as other manufacturers make these cabinets. How do we know how we need to make these cabinets? So we are held to a standard that we all refer to as NSF 49. This standard is put out by NSF and ANSI International, and this standard relates to how we design, make, and test our biosafety cabinets. There's very stringent performance requirements that all manufacturers must make to have an NSF listed biosafety cabinet. And these include vibration tests, lighting tests, material construction tests. They include, most importantly, the biological challenges. So all cabinets go through a biological challenge with actual bacteria to make sure that they contain and do what they're supposed to do when delivered. Other global standards exist outside the United States, even though NSF is recognized by several other countries. The World Health Organization has specifics on their cabinets. In Europe, the EN 12469 standard typically applies to biosafety cabinets, and then there are more throughout the world. So overall, how does a biosafety cabinet work? First, the first thing a biosafety cabinet always has, just as I mentioned earlier, that a fume hood does not have, is some sort of filtration. HEPA filters or ALPA filters are commonly used to filter out the viruses, the bacteria, or particles that you may be working with. These filters are either on the exhaust side, and some cabinets, as we'll discuss, also have a supply HEPA filter as well. In conjunction with the HEPA filters, airflow is used to make sure that the biohazards stay within the cabinet, are drawn away from the user, to provide personnel protection and also provide that airflow is used through that HEPA filter to provide product protection. In the image you now see to your right is you see a little bit of smoke being drawn into the front of the cabinet. This is just a picture of how this air is pulled in and then distributed under the work surface to stay away from the user. As far as biosafety cabinet classes, there are three main classes of BSCs. The first class would be a Class I biosafety cabinet. This is a negative pressure enclosure whereby airflow is drawn in the front of the cabinet, pulled through across whatever you're working with, whatever samples you might have, and then passed through a HEPA filter before entering back into the lab space. A Class II biosafety cabinet is very similar in that it has an inflow air to protect the operator, but it also has HEPA filtered downflow air. So this protects the sample from any contamination as well. So Class II biosafety cabinets protect both personnel and the product or research that's being done inside the cabinet. They have two HEPA filters, a supply and exhaust HEPA filter. And then there's a third class of biosafety cabinet, and these would be called Class III BSCs. These are fully enclosed designed, commonly called glove boxes or referred to as a glove box. They have both negative and positive pressure. They protect both the person and the product working with them, and they're a fully enclosed design. They have a supply HEPA filter with air coming in through the top of the unit to protect the product. And then they have two exhaust filters going out of the box as well. They typically have an antechamber that can be sterilized or some sort of a dump tank that all products going in or out of the glove box must pass through a disinfectant before being taken in or out. For this next part of the presentation, we're going to focus on the Class II BSC and the different types. These are the most common biosafety cabinets by far, and so the different types are what we'll talk about next. As I mentioned in the previous slide, the BSC, the Class II BSC, provides personnel protection by pulling room air into the front of the cabinet. This air then passes under the work surface. It goes to a shared plenum and then is exhausted out either into the laboratory or downward over the work surface after passing through a second HEPA filter. The exhaust airflow and the supply airflow are HEPA filtered. This HEPA filtered air in most cabinets returns to the room. The inflow air is around 100 to 110 feet per minute, and product protection is provided by the supply downflow air. Downflow velocities tend to vary by manufacturer, but usually range in somewhere between 50 and 60 feet per minute. The video that you're currently seeing is a smoke visualization of what that laminar flow downflow air looks like. So we have a very gentle HEPA filtered downflow that's kind of bathing the product or the process that's happening in the biosafety cabinet to protect it from any contamination that might occur from outside the room. At the top of a biosafety cabinet, you have some main components that kind of make the whole process work. First, we've already talked about, and perhaps the most important parts, are the supply and the exhaust HEPA filter. Next, you're going to have a blower. Some models even have two blowers. This is what's providing that airflow movement through the cabinet. And then you're going to have some sort of a plenum, and these plenum designs will vary depending on the type of BSC, which we'll get into shortly. So in the next section, we're going to cover the different types of Class II biosafety cabinets. And although all of them are going to have an exhaust and a supply HEPA filter, the plenum and the blower configuration are going to vary. So the different types of Class II BSCs are defined by type. So this would be a Class IIA2, a Class IIB1, a Class IIB2, or a Class II Type C1. These are the most common that are out there on the market today. The main question to ask as you're trying to sort through what type of biosafety cabinet or what type of Class II biosafety cabinet you need is, Are fuming or volatile chemicals being used in the research? And if so, how much? One of the questions we get a lot at LabConco is there's all these different types of Class II BSCs. How do I know which one I need to use? And first, I want to just start out before we dive into all these types and what's different is all of these types are equally safe for all biohazards. What the difference is and how you differentiate between these different types is if you're researchers or if you are going to be using any type of fuming or volatile chemical in your work. Okay. And the reason for that is that fuming chemicals are not trapped by HEPA filters. So let's say you had a process that involved some work with phenol chloroform. You would not want to do that in a standard recirculating biosafety cabinet that didn't have any exhaust because those fumes would pass directly into the laboratory and be exposed to the users. So the main difference in all of these different types of biosafety cabinets that we're going to talk about is how they exhaust those chemicals, how the airflow is handled between an A2, a B1, a B2, and a C1 is all very different in how they handle the exhaust air. Okay? So when looking at these cabinets, it's not necessarily about the biohazard risk you're working with and what type you need. It's more about the chemical risk and how much chemical you're using. Okay? We're going to talk about some different diagrams of each of these cabinets, and you're going to see these diagrams now on your right. I'm going to walk you through each of these, but the one main thing I want you to notice just in looking at these images right now is that they're all very different in how the exhaust is handled. And so that's what I'm referring to when we talk about the differences in the A's, the B's, and the C's. It's really about how that exhaust air is handled should you be using any type of volatile chemical. The most common BSC that we come across, and the most common that you will find out in the world, is going to be the Class II type A2. I would call this your standard microbiological biosafety cabinet. Okay. This cabinet provides both personnel and product protection, as it is a Class II. As the airflow comes into the front of the cabinet, it's driven under the work surface, up the back of the biosafety cabinet, and into a shared plenum. Some of this air at that point is either pushed through the exhaust HEPA filter back to the lab, and some of the air is pushed back down over the work surface to provide that product protection that we require from our Class II biosafety cabinets. In the drawing that you see below, what I'm trying to represent here is that all of the supply air in the cabinet is coming from the intake air, okay? Meaning that it passes over our sample and it's recirculated and comes back down. This is very common for these Class II type A2 recirculating cabinets. Now, what happens in this situation if I have some chemicals that I would like to use that are fuming? Okay? There's two problems that exist with trying to use a fuming chemical in this type of cabinet. The first problem is that it's not going to be trapped by the HEPA filter and it's going to be pushed back into the laboratory. Okay? The second issue arises in that some of my chemical, some of the airflow in the cabinet as it's passed over and picks up those fumes is not exhausted, but is pushed back down through the supply HEPA filter into the cabinet. So one could imagine a possibility where over time, if I was working with a large volume of chemical, since all of this air is not exhausted, it can start to increase in its concentration inside the cabinet. So the first thing that we can do if we need to exhaust a biosafety cabinet and we're only using a very small amount of chemicals is we could put what we call an exhaust canopy on top of our Class II type A2 biosafety cabinet. This connection is provided by each BSC manufacturer and sits on top of the cabinet and allows you to connect your Class II type A2 to ductwork. What this means is that all of the air passing out of the top of the cabinet is going to be exhausted. However, if you read the BMBL, and for the reasons I previously stated, this type of setup with this canopy connection is really only good if you're using very small quantities of chemicals. Because remember, I mentioned that some of the airflow is being recirculated back in the cabinet. So you want to make sure that any of these chemicals, the concentration does not build up over time within the cabinet. So this works well for small quantities of chemicals, or sometimes if you just have an application that has unpleasant odors that you don't want being released back into the laboratory. So, what happens? Let's say your researcher has a larger volume of chemicals they want to work with, and you decide that a class 2 type A2 is not going to be adequate for that research. So, in summary, for the type A2, these are suitable for many biosafety applications, and they can be exhausted with a canopy connection provided by the manufacturer for small volumes of chemicals. They're easy to exhaust in that you can connect them to kind of a general laboratory exhaust system. And they typically are lower cost of exhaust compared to the class 2 type B2s, which we're going to talk about next. The downside is they're not suitable for medium to high volumes of volatile chemicals. Another downside is they can't really be converted into a chemically friendly biosafety cabinet, meaning they are always going to be only for those low volume chemical usage. Okay, this brings us to the next class of biosafety cabinet, and that's going to be the class 2 type B1 and B2. Now, B1s are not quite as common as the class 2 type B2, but I wanted to bring them up just in case you have heard of them. Now, in a B1 style cabinet design, a portion of the cabinet is recirculated, like in the A's. However, a portion of the cabinet is also what we call 100% exhaust, meaning that it's single pass airflow. And as that airflow moves through the cabinet, it's directly exhausted. Now, for a class 2 type B1, that happens to be this red area in the back of the cabinet. That's where we are provided 100% exhaust from our chemical usage. So, in this style of cabinet, if you wanted to use a larger volume of chemical, you'd want to make sure that your bottles were kept towards the back of the cabinet. In the middle of this cabinet, if you recall the video that we showed earlier in that downflow air, part of the air moves towards the front of the cabinet and part of the air moves towards the back. So, this split in how that airflow comes down the cabinet really defines the chemical work area. So, you would always want to make sure your users are working in the back of the cabinet for where that 100% exhaust air is. Each of these BSCs require a dedicated exhaust blower and exhaust duct for each BSC. The reason for this is that unlike the class 2 type A2, where the internal blower is providing some exhaust, in the type B cabinets, the exhaust is 100% relying on a remote exhaust blower. These are typically located out on the roof of the building. This is the only blower within a B style cabinet that's providing exhaust. Because of that, B cabinets have very strict regulations that the internal blower, which is providing that supply downflow air to protect your product, must shut down within 15 seconds of detecting a remote exhaust failure. From the side view, you can see a little bit about how this cabinet works. Inflow air still comes in the front, as denoted by the orange arrow, and the air passes underneath the work surface. However, you notice in the back, there's a little bit of a split plenum. So depending on where the airflow is going out, coming from the front or the back, depends on if it takes the exhaust pathway or if it's circulated back around into the supply pathway. Different from that one, we have the class 2 type B2. This would be considered a total exhaust cabinet, where 100% of the air that passes over the entire work surface is exhausted. There's a remote blower out, again, usually on the roof, that pulls air into the cabinet and again exhausts 100% of the work surface. The downside to these cabinets is that they have a very high CFM requirement. And what CFM stands for is cubic feet per minute of air. So that's how much air is pulling through the cabinet and being exhausted. These cabinets also require a dedicated exhaust duct and exhaust blower for each BSC. Similar to the B1, the internal blower will shut down within 15 seconds if the remote exhaust system fails. The drawing to the right shows a little bit about how the plenum design works in a Class II Type B2 cabinet. You have your inflow air in the front, which passes under the work surface. All that air is directly passed up to a separate exhaust plenum and then is pushed outside the building. The inflow air that's supplying the product protection comes in from the room. Air is drawn in through the top of the cabinet, is pushed through a HEPA filter down over the work surface, and then all of that air is also exhausted directly out of the room. The pros of the Class II B2 cabinet is that they provide maximum exhaust for chemical safety. 100% of the work surface is exhausted. You don't have to worry about any air recirculating around the cabinet. However, the downside is that these cabinets must always be ducted. They must have a dedicated exhaust run for each BSC, which can increase design costs and installation costs. The BSCs must shut down within 15 seconds of an exhaust failure, which what happens in those 15 seconds before the cabinet goes into alarm, you need to make sure you do some smoke tests on your units in your facilities to make sure they maintain containment. And they have a high operational cost, and that's because of all the air that they're exhausting out of them. Another downside of the B-style cabinets is that they're always a B-style cabinet. Let's say your research changes, for instance, and you no longer need to exhaust your cabinet. You can't just turn a Class II Type B2 cabinet into a Class II Type A2 cabinet, because unfortunately, the B2 relies on the remote blower outside for its exhaust. The last type of cabinet we'll talk about, which is the C of the ABCs, is the Class II Type C1. This cabinet is a combination of an A2 and a B2. This is a two-blower cabinet with an independent supply and independent exhaust plenum. In that way, it's a little bit similar to the B-style cabinet. This cabinet provides 100% exhaust air, but only in a designated spot of the work surface. This cabinet can also be connected to a general lab exhaust system, and it does not require the use of a specific dedicated remote blower. The side areas and the areas that you see here in blue are recirculated similar to an A-style biosafety cabinet. Now, what this gives the user is it means that this red rectangle in the center is what is called the chemical work area. This area is providing 100% fumes. However, the sides are recirculated through the cabinet similar to like a Class II A2. This really reduces the CFM requirement on the room and how much exhaust is pushed out of the building. Another nice feature of the Class II Type C1 is that should there be a remote exhaust failure on the building, the second blower within the system, the exhaust blower, can speed up and run to help maintain that exhaust for up to 5 minutes, giving the user time to cap their chemicals and get everything closed up. This means it provides the maximum safety over the traditional Class II Type B2 cabinet. The internal exhaust blower can compensate for a short time during the exhaust failure to allow for that cleanup. The Class II Type C1 is also flexible. It does not have to be connected to an exhaust system. It can exhaust to the lab just like an A2 cabinet would. Should the application change, it can be connected to ductwork, recertified, and exhausted and switched to B mode. And the defined work area on the Class II Type C1 clearly allows your users to know where they should safely handle chemicals and where they shouldn't. So a little bit of a recap on these biosafety cabinets. The Class II Type A2 is the most common biosafety cabinet out on the market. It can be vented or exhausted for small volume of chemical usage. and it can be connected to a general lab exhaust system. The Class II Type B2 is a 100% exhaust design for high volume of chemical use. However, it can have an expensive installation and operating cost. The Class II Type C1 is flexible. It can work in Type A mode or B mode, which would be exhausting that center work area. It has an easier installation because it can be vented and connected to a general exhaust system. And it provides several additional safety features when vented over what Class II A2 and Class II Type B2 cabinets can provide. So this last slide, basically what I wanted to summarize is a question that we get a lot on biosafety cabinets is how the operational costs compare between the different types, the A, the B, and the C, and where does that come from? So as I discussed a little bit about the different cabinet types, the amount of air exhausted between an A2, a B2, or a C1 when connected to exhaust can vary. As the A2s and the C1s recirculate some of their air, they exhaust less CFM, less cubic feet per minute of conditioned lab air, which means that your lab doesn't have to make as much conditioned supply air. This is really where that cost comes into play. Overall, the Class II A2 with canopies or Class II C1s with a canopy or exhausted are going to have about half the operational cost of the B2 style cabinets.
Thank you again, Elizabeth. We will now start the live Q&A portion of the webinar. If you have questions you'd like to ask, please do so now. Just type the question into the Ask a Question box in the left and click Submit. We'll answer as many of your questions as we have time for today. Let's go ahead and get started. Our first question here is, how do I know if the amount of fuming chemical I am using requires an A2 with canopy or if a B2 or C1 would work?
That's a really great question. And this is another area where your institutional EH&S committee can help out. What couple of the things you need to consider is, one is that if your volatile chemical is flammable, you want to make sure you're working well below the lower explosive limit of that chemical. And remember, in an A2, some of that chemical is going to be recirculated in the cabinet versus being directly exhausted like it would in a B2 or a C1. So really kind of knowing how much is your chemical is volatilizing, how much is in the air. It's really going to help with your determination of if an A2 is going to work or if you require a B2 or a C1.
Excellent, thank you. Our next question here touches base on that last slide. It says, what is a Class II A2 or A/B3?
Okay, that's a great question. So those cabinets so as NSF and the organizations that regulate biosafety cabinets, as safety standards have progressed, some cabinets are no longer made. So the A/B3 cabinet has been replaced by the Class II Type A2 cabinet currently. So if you're looking at replacing an old A/B3, your direct replacement on today's marketplace would be the Class II A2.
Wonderful, thank you. All right, our next question here, how do I know what BSC is best for my specific biohazard?
That's another really good question, and one that we get quite often. And basically, when it comes down to working with biohazards, all types of biosafety cabinets are equally safe. However, what you need to be really specific on is what is required for your biohazard in terms of personal protective equipment or PPE. Some biohazards, say if they are risk group 3 or 4, are going to require, possible personal respirators as well as working in the cabinet, face shields. Some require double gloving, things of that nature. So as far as, working with a risk group 1 through 4 bacteria or biohazard, the cabinet is going to remain fairly consistent. However, your room conditions and your personal protective equipment that's required is going to change.
All right, wonderful. Our next question here is, I'm not clear on why a C1 is more beneficial in a cell culture room than a B2. Can you explain?
That's a really good question. And it depends again. The B2 or C1 would be the cabinets you would look at if you're using chemicals that require exhausting. A lot of times, cell culture rooms or cell culture suites are very small. So you maybe have one or two cabinets in there and a couple incubators and maybe a counter and a sink. Now, depending on how many air changes per hour in your HVAC system that you have in that room, it could depend on, the B2 cabinets is going to exhaust a large volume of air. It might be the case that your HVAC system cannot keep up with those cabinets. In that case, a C1 would be a good recommendation because its exhaust volumes are a lot lower and it still provides you with that 100% exhaust in that chemical work area.
Excellent. Thank you. It looks like we just have one more here in the queue. So if anybody has any questions, now is the time to submit them. Again, in the left-hand side, submit your question and click submit. We will answer it here. If we don't receive any more, our last question here is, what kind of enclosure would you recommend for automation equipment?
That's a great question, and one that we get more and more often these days. Traditional biosafety cabinets are designed around a user sitting and working, usually doing their cell culture or something like that. Now, when it comes to automated equipment, this could be a liquid handler or something that's pipetting liquids into plates for you or things like that. You're really defined by the size of the cabinet as far as what equipment you can place in it. There are larger Class II enclosures that are available. They're not classified by A, B, or C, but most of them work similar to what you would find a Class II A2 in that they can be exhausted or recirculate to the lab. And they're larger, what we call Class II enclosures that can encapsulate larger automated equipment. So they're kind of like a biosafety cabinet, but they're much larger. And they can provide that downflow air to protect your product and HEPA filtered exhaust air, or that air can be exhausted outside via canopy connection as well.
Excellent. Thank you so much.
Mm-hmm.
Elizabeth, did you have any final comments for our audience here today?
It looks like there's one more question that just popped up.
Yes. Okay. What is the lifetime for A2 hood and how is the maintenance on that?
Okay. So typically, it kind of depends based on manufacturer, but at LabConco, we would say our biosafety cabinets have about a 15 to 20 year lifetime. And that being said, we have biosafety cabinets out there that people call about, I know, that are over 20 years old. So that being said, sometimes it's not about how long the cabinet is going to last, but how the safety rules and regulations change over that time. We had a question earlier about the A/B3 style cabinet, and those just aren't made anymore because they just couldn't keep up with today's safety standards. We've found better ways to exhaust cabinets. So while biosafety cabinets can last a very long time, typically we would say every 15 years or so, you should probably review replacing your cabinets, just because the technology changes and the safety, the way they contain improves over time. We often get asked about the HEPA filters. How long will they last as well? HEPA filters in a biosafety cabinet can last 7, 10 to 20 years. It really depends on, one, if your process is generating a lot of particulates or dust, your HEPA filters are going to be used much quicker. Or if your labs are very dusty or dirty, the HEPA filters are going to not last quite as long. But in a general cell culture lab, I would say you could expect 7 years or more out of your HEPA filters. As far as the maintenance, biosafety cabinets are certified usually on an annual basis in some GMP and cell culture facilities or pharmacy applications, they're certified every 6 months, which means that a certifier comes in, they make sure the inflow and downflow are correct, they scan the HEPA filters and check for any leaks, and just make sure the biosafety cabinet is performing as it should.
Okay, wonderful. And we don't have any more questions here in the queue just yet. So at this time, do you have any final comments for our audience?
I don't. I would like to thank everyone for listening today. And if you have any questions, please feel free to reach out to us here at LabConco. We have a great online chat feature that is a quick way to get answers to some of your questions. Please don't hesitate to reach out and ask.
Thank you again, Elizabeth, for your time today and for your important research. We would also like to thank LabRoots and our sponsor, LabConco, for underwriting today's educational webcast. Until next time, take care, everyone. Goodbye.